Hi, kids. Okay, we're going to use this PhET simulation to learn some basic stuff about waves. So, if you're going to follow along with the simulation, it's a really good simulation. But I am going to set this right here to 0. That's like how much friction there is. So let's do this. Let's make it so there's no end. So my wave's going to go right out the window. But if I make a pulse, so let's say I'm going to make a pulse here and send the wave. Do you see how it's dying down because there's dampening? Well, we're going to do this. Why? Because we're going to start talking about light, and light, as long as it travels through the vacuum, really doesn't die down. But you can see, hey, it's moving along. So let's talk about just some basic stuff. First, just so you understand, wave speed is literally how fast that thing moves along. And if you wanted to, we could measure speed the old way that, hey, you could go distance divided by time and, do distance divided by time. And that's how fast it moves along, okay? But with talking about waves, if I have a bunch of waves continually happening, so you can see, hey, look at my amplitude here. You can look at my frequency here. And let's make sure we understand what amplitude, frequency, wavelength, period, all that good stuff is. So if you take a look, so first of all, okay, if we were talking about waves, okay, the wave speed, it's literally how fast this wave right here is going to move along. So if I hit play, that wave moved along. Oh, one went out the window. So if I do it again, it would be like, all right, literally, if I talk about this wave, how fast it moves along. So it's moving along and it went out the window again. So hopefully that makes sense, okay? We could, again, if we wanted to measure that distance in time, we could, but I want to make sure you understand wave speed is literally how fast the wave moves along, which you should know the units for that, meters per second. Duh, okay? Amplitude, if you look right here, it says 0.75. So let's take a ruler out, and we're not going to worry about this ruler, but I want to try to see if I can figure out what is the 0.75 that it's talking about. So if I do that, let's measure. If I put up my 0 right there on this reference line, and let me just pause it for a second, okay? Do you see the amplitude is measured from that midpoint to the highest point, or from that midpoint to the lowest point? Does everybody see that? Okay, that's amplitude. So just be careful, make sure you're measuring it correctly. But it's how big the wave is. If I hit run, and let me get rid of my rulers, and I make my amplitude smaller, you can see the wave is smaller. If I make my amplitude bigger, you can see my wave is bigger. So amplitude literally is how big the wave is. If we are talking about sound, and I would like to make bigger waves, well, I need to do this! Okay, that would be a bigger wave. If I would like to make a smaller wave, I would do that. Okay. So that's amplitude. So hopefully make sure you label it, make sure it makes sense to you, okay? Let's talk about wavelength. So wavelength, surprisingly, it's the length of the wave. I know, crazy, isn't that? So if we were trying to measure the length of the wave, then let's get rid of this one. I would want to use this one because that's how long the wave is. And you would go from where the wave starts to where it starts to repeat. So in this case, it looks like this wave is roughly 4.2 centimeters long. Or if you wanted, I can measure from here to here because that's where the wave starts to repeat. You can see it's roughly 4.2 centimeters long. If I wanted to, again, I could pick this point to this point right here because that's where the wave starts to repeat. So wavelength, surprisingly enough, is how long the wave is. Amplitude and length are going to be measured in meters or centimeters distance because it's how big or how long, okay? So that's wavelength, how long one wave is. Make sure you can label that. And then frequency. Let's talk about frequency. So it is literally called frequency because it's how frequent a wave is occurring. So that, if I was to say, hey, I want to know how frequent a wave is occurring, if I start my stopwatch, ready, 1, 2, 3, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So according to this, there were 10 waves in this much time. Now, I don't know how accurately I measured that because I was just doing it, with this, and I'm old. But if I go 10 waves divided by 6.63 seconds, hey, what do you know? I got like 1.508. It's pretty darn good. But I get that many waves per second. Okay, so it's how frequent a wave is occurring, which is going to be the number of waves per time. Frequency is measured in hertz, which is waves per second. Okay, so hopefully that makes sense. And then if you wanted to know the period is literally the amount of time it takes for one wave to go by. Okay, so in this case, we had 10 waves go by in 6.63 seconds. So my period would be 6.63 divided by 10, because it would be this many seconds divided by that many waves, which is 0.66 seconds. So every single second, or every 0.66 seconds, one wave would go by. And the nice thing about this simulation, I can actually pause it, and if I go like this, so let's say, do we see, if I stop like right here, do you see how the crest is exiting my window? If I reset this and then I hit play and I go frame by frame, we can see it takes, I think I went a little bit too far, but you could see it was 0.66 seconds for it to go out. So period is the amount of time it takes for one wave to go out. And then if you look on your formula sheet, you will see that the relationship between frequency, by the way, is going to be a lowercase f because we already use uppercase F for force, and period, they are inverses of each other. So make sure you find that on the formula sheet. And that is pretty much your intro to waves. I should say this one more thing. Just we do one more thing. Let me get rid of this and this. Okay. I do want to show you that if I increase the frequency, does everybody see how I did not change the wave speed? If I decrease the, here's this. If I increase the frequency versus decreasing the frequency, does everybody see the wave speed doesn't change? So, but if I increase the frequency or I decrease the frequency, you can see the amplitude, not the amplitude, sorry, the wavelength does change. So bigger frequency, does everybody see smaller wavelength? Smaller frequency, you can see you have a bigger wavelength because there is a relationship between speed, which is staying the same, frequency, and wavelength, okay? So how do you change the speed? Well, we'll talk more about this later, but if I change the tension, you can see it immediately changes the speed, okay? But more on that later. I think that's good. I hope that's good. Bye, kids.